Calc students, believe it or not, it is time for your last calculus unit review. One thing to be aware of is I have skipped over the derivatives with implicit and a few other things in there. I'll probably end up assigning that for a later week. But for now, I'm hoping that you're still seeing those skills integrated into what you're doing currently, so we don't have to review that too much. But either way, let's get into differential equations. 11 questions, so the shortest one so far. All right, so let me read this for a second. Okay, so this equation, or this question, essentially comes down to understanding proportional and inversely proportional relationships. Long story short is proportional relationships will multiply by some unknown value or unknown constant, and inversely proportional will divide by that constant. So long story short, the answer we look for is actually going to be right here. And so let me just describe that quickly. What it's saying is it is proportional to z. In other words, the rate of z over time is proportional multiplying by some factor with z, and it's also inversely proportional to the volume at any time. And they give an equation for volume at any time, which is 20 plus 2t. Inversely means divide by k. Proportional means multiply by k. And the one key here is that it says it's decreasing, so that's why there is a negative out front as well. All right, up next it says the initial condition is 0, 1, and what is the range of the solution curve from x equals 0 to or x is greater than or equal to 0. The idea about this is you need to invisibly kind of put your mouse or think about a point right here, and typically in a general differential equation question, we usually don't just care about from x equals 0 to infinity. Typically we care about from x equals just all values in the domain. So just saying, there are times maybe on the AP exam where you might need to think about the range being all of this. And you can kind of see how my mouse is going. I'm hinting towards what the solution is. But in this case, we only care about 0, 1 to infinity. And so obviously the range is going to be at 1. And if you follow this slope, it will take you along this path. And notice that this is essentially an asymptote line. So you will touch the exact value 1, and you'll go up to, but never equal 4. And so the way we write that is like this. All right, up next, in drawing the slope field for the differential equation dy dx equals this, I would place short line segments at the selected xy points, and so we just have to see essentially what we're saying is what is the slope at these particular points, and all you have to do is plug in this for x and this for y into the equation and solve. So I'll do that really quickly. So for the first one, dy dx would be -2 plus 0 minus 2, and so that would end up being -4. For the next one at 0, 3, hopefully you kind of see what it did. Well, I'll do it. Why not? We've got time. This time it's going to be 0 plus 2 times 3 minus 2, and that's also going to end up, well, not also, but it's going to be +4. And then at 1, 1, you plug in 1 here, you plug in 1 here, you're just going to end up with 1. Up next is y a solution to this differential equation. Remember that y prime means the derivative of this, so I've got some work to do here. First, let's calculate y prime. Y prime is actually just going to be -2/3, and the question is, does that equal, sometimes we write it like that, 2x minus 3 times y itself, which is -2/3 x plus 1/9. So I'm substituting y with what it's equivalent to, -1. And now I've just got some algebra to deal with, so -2/3 is that equal to 2x, if I simplify this, this is going to be positive 2x minus 1/3. Whoops, sorry, that doesn't distribute. Minus 1. And so what I see here is that, unless I've made some grand mistake, oh sorry, it's plus, so I have made a grand mistake, silly me. So that should still be negative, that should still be positive, so the 2x and negative 2x cancel out, and then I have positive 1/3 and negative 1, and that means I'll be left with negative 2/3, so does negative 2/3 equal negative 2/3? And the answer is yes. So it is a solution. Long story short, for a differential equation, what you need to do is replace y with the function itself and replace y prime or even possibly y double prime wherever you see it in the equation and see if the left-hand side equals the right-hand side. Up next, we've got a step-by-step solution here. First thing the student did was they distributed out the 2x. That seems correct. Next, they separate the variables by dividing the y minus 3 and multiplying the dx. That seems correct. Up next is that ln of absolute value y plus minus 3. Yeah, that does seem to be correct. Yes. Okay, the mistake is right here in step 4, because technically if you decide to raise the left-hand side all to the, or if you decide to make the left-hand side the exponent of e, you have to make the entirety of the right-hand side the exponent of e. In other words, the plus c1 should be up in the exponent as well, so that's where the mistake is. So just like the whole ln structure gets put to the exponent, the whole right-hand side should also be an exponent, so that is where the mistake is. Step 4. Yep. All right, so now it's time to solve a differential equation. The thing about this is, it's not really a differential equation. This is actually something we've kind of talked about recently. It's the new position function. So, let's see how we can do this. Let's first integrate f prime. If we integrate f prime, remember integrating f prime takes you back to f. So we'll end up getting, let's see here, this was x to the 4th and a 4 dropped down. So that must have been 2x to the 4th. That's how you drop down the 4 and get 8. Minus, it looks like 6x squared. That's how you drop a 2 down and get negative 12 and just have a single x left over. And then this is indefinite, so we have this plus c. Now this time, the other thing is this is kind of like a function of x. So this time we need to be able to plug in 1 and get 1. So in other words, 1, the y value, is what you get when you substitute 1 in for x. So what is c? And so that means we have 1 equals negative 4 plus c, and that means c is equal to 5. Okay, so let's update our equation. We now know f of x is 2x to the 4th minus 6x squared plus 5. We now know what c is. And now they want to know what f of negative 2 is. So now I'm going to plug in negative 2. Negative 2 to the 4th is going to be positive 16, so times another 2 would be 32. Negative 2 squared would be positive 4, so this would be negative 24. And then plus 5, so that's going to be 8 plus 5, so f of negative 2 is 13. I went pretty fast through this. Whew. All right, next. Make a box here. All right, up next. So we have dy dx, and it's actually the same prompt. We just have to go through different steps here. Oops, my chair made some noise. In this case, whenever you solve by what we call separation of variables, which is what we're doing here, you always want to simply get like usually y or the unusual variable as by itself as it can be. So in other words, I'm going to only divide the y squared. I can't get rid of the exponent, but I'm definitely going to keep the 2 with the dx. So really what I've done here is I've divided by y squared and I've multiplied by dx, and this is what they mean by separation of variables. All my y's are on one side, and all my x's, well there's not really an x here, but my x, my dx, and any other constant or something going on here is going to be on the other side. Up next, we integrate. Again, be careful, this is not an ln because it's not dy over y. This is a reverse power rule, and you'll end up getting negative y to the negative 1 equals, and this will end up being 2x plus c. So I know I'm kind of skipping past some integration techniques here. Hopefully this makes sense to you. And actually, it might be better, as we solve this problem, to write this as negative 1 over y to the positive first. So in solving for y, the first thing I'm going to do is distribute or multiply by negative 1. Negative 2x. Technically, a minus c is still a plus c, so the c can absorb the negative, that's okay, but theoretically you could write minus c, but I'm not going to. Up next, here's the key idea here. All of this is technically over 1, so if we want to solve for y, we just have to flip this fraction, which means we have to flip this fraction. So now it's y equals 1 over negative 2x plus c. And we're told that y of 1 equals negative 1, so in other words, negative 1, the y value, equals 1 over negative 2 times 1 plus c. So in other words, this denominator just needs to be negative 1, and so I'm going to kind of skip that. Hopefully you see how that works itself out. It means c is positive 1. So now I know in general that y of x is 1 over negative 2x plus 1. And the last thing they want me to do is plug in 3 for this. And when I do that, I'll end up with 1 over negative 5, or in other words, negative 1/5. Again, I'm going kind of fast. Hopefully I'm not making mistakes.